Okay. First of all, okay, just to give you, okay, next, this is the content of today, about some terms we will speak about, okay. What's mean by some of the definitions on the fiber optic world, okay. Some of the means of names like attenuation. Attenuation, its definition for the reflection, okay, of the signal and the loss of this reflection. Okay. To understand all of these terminations, I will just pass this as a quick history. On 1840, some guys developed idea by using the water and some opening on the hole of the water tank, okay, and they try to pass light. They try to see if this light is coming out or it's where it's going. They found that the water itself is creating a reflection. Okay, the water does not come straight or it's going as an angle with the water. No, it's coming as a reflections, as a waves. Okay, and this wave change as far as you change the source of the light and the angle of the light. So they change the source and angle. Very, very, very big, very important point or VIP point, which is angle and source. Okay. Based on this, they have come up with the idea that I can utilize this type of way, okay, of doing water, okay, to develop a new idea which is for the communication level. So they invented the glass, which is the main content of the fiber optic. It's a glass. It's a pure glass, okay, where they try to change the light and to utilize it to transfer information from A to B. This is the main purpose of the fiber optic. Transfer data from A to B. This data may be data, not normal data, maybe telephone data, maybe voice signaling, maybe only just machine signaling. Okay, so this invention of the fiber optic has been designed, okay, not to use the coaxial anymore, to go for better and best performance, which is the fiber optic. Okay, so they invented this on 1930. They started to use it for transmission of the pictures. They found it's more fast, okay, and more reliable solution for them. So they started to develop it. 1960, okay, for some small, okay, small applications on the military, actually. And then on 1970, they started to use it on little bit bigger communities, where they found that the type of the glass itself, it's a big issue. On that time, there was no factories to build the glass. Okay, just only normal by heating and producing by normal guys who's working in the workshops. Okay, so they produce this glass where they use it, but still they have a very, very high loss and it's not transferring the full information. Okay, so they started to develop this idea, to develop this manufacturing level. Okay, till they came to the stage where, okay, now we can really use this fiber optic, which is around 1980. The first communicated city, it's in UK. They have developed the communication between the small guys on the city. They use it and it was working fine. Then it's come to people just all over the world by the first development of AT&T. They're the guys who developed this solution in USA, AT&T, but it was around 1975, 1976, for the military jobs only, where they have money, they have funds, because at that time, the manufacturing of the fiber optic was too costly. Nobody can afford to pay for it. So the army got this as a project, and they started to develop it, we come to the stage, yes, we can utilize this in our communication. Okay. And to understand more about this, there is another one slide. How this works exactly as a fiber optic. The fiber optic content of simply it's light. Source of light and angle of light goes inside the bypass. This is the bypass, okay? Then the source and angle will determine on which way this cable or which way this light will go. And on that time of 1970, they found that your eye and my eye and your eye cannot identify anything above of 850 wavelengths. You can identify the 7 colors, but above 850 micro wavelengths, nobody can identify by his own eyes. So on that level, they developed the fiber optic technology, where they can use 850 nanometers, 1/300, 1/550, and then 1/600. This is the main wavelengths for the fiber optic. Okay. This is where they developed the fiber optic technology, where as a human being cannot see it, but it will give a good signaling, and it will be used the signal of the light. You can change it based on the frequency and the wavelengths, and based on this you can use it in your application. Okay, so to identify which wavelengths, you need to know which is the source application, what is my source, and what is the end application, what I need to connect to where and to do what. Based on this, you will identify the wavelengths. How? Based on this idea, you have to understand what is meant by fiber itself. The fiber consists of 3 main elements. The first of all, the coring, which is the first core. To understand it, this is in single slide. Okay, there was on the manufacturing, on the production level, okay, based on the wavelengths, they developed 2 levels of fiber optic. The first one, which is the multi-mode, and the single mode. This is the main 2 types of fiber optic. Multi-mode is used mainly for the small applications and the small distance application. Single mode used for the long distance application. Still, we can use a single mode for the short distance, but for the high performance network, where you need something to connect last in and the full network single mode, you can even utilize the same single mode.
Sorry for this.
Single mode.
Again, please, this point.
Again, the main difference between the single mode and the multi-mode, that the multi-mode is used for the short distance,
Multi-mode.
up to 2 kilometers.
Okay.
Okay, and the single mode cable can be used up to 70 kilometers.
The big difference.
This is the big difference between them. Okay.
For
Why to use
Ah.
single mode and multi mode depend on the application, which we said in the beginning. Application, what I want to connect from side A to side B. What is my end application? What is my end services? If just only for machine connectivity and the distance is small, I can use a multi-mode up to 2 kilometers. Because machines will communicate with each other only around 10 megabytes, 50, maximum 50 megabytes. So the multi-mode on the 2 kilometer can give you up to 100 megabytes. I will give you all of this on the slides. Okay? To understand the difference, multi-mode is for the short distance, single mode, long distance. Okay, how it's working? First of all, that this fiber itself, this is the full coring of the core, cladding, and then the coating. This is the one.
والله احنا شفنا دي كل الحاجات دي.
Yes. Okay, you can imagine that this is a micro by micro, not by centimeter or millimeter. No, it's by micro. and the thickness of the fiber itself on the two type of the fiber. This is the difference between them. Single mode, the diameter of this fiber optic, it's 9 micron. Diameter of the core itself. And on the multi-mode, there are two diameters, 50 and 62.5. The 50, of course, it's for the up to 2 kilometer. 62.5 is a little bit lower or shorter distance, which up to 500 meter, 400 meter maximum you can go. And this is the cladding 125 micron, which is for both of them is the same, 125 micron. Okay, and then the coating, which is the protection of the cable itself, where it's the coloring of the fiber.
Is it single mode or multi-mode?
This is single mode cable, and the multi-mode will not be different. You will not identify the difference.
by
Don't see the difference.
No. Okay, to identify the number of the fiber cores inside the cables,
Maybe
they
single-
invented the idea of the coloring code. There is a 12 coloring code, okay, which to identify, this is the maximum coloring code, so to identify the number of the fiber optic inside the cable.
Identify the cores and
Yes,
number
to
of
identify
cores.
the number of the cores per
Mm.
cable.
By color.
No. Just wait, guys. Okay. There is not much difference. You can see it by your own eyes. Careful on the dealing with the fiber. Careful, because it will hurt you. Careful. Yes, please. You will not sleep tonight. That's it. Please, yes. Your eyes cannot identify the difference between the multi-mode and the single mode. Okay, only on the machines will identify this. Only on the splicing machines or on the testing machines will identify this fiber. Okay, and based also on the solution that you are putting, based on what is written on the cable here. Okay, they have to identify. Usually, you can identify it after some experience by the color of the jacket. The yellow used for the single mode, and other colors is used for the multi-mode. Okay, as a jacket outside, as an outer jacket,
So always yellow, single mode.
single mode. I'll show you all this outer. Understand how it's working inside. This is how the single mode works and how the multi-mode works. The definition of the single mode is just to unify the signal. One simple signal goes from A to B. So he unified, so this is why he can go more distance. He can reach up to 70 kilometers. But on the multi-mode, the waves became more waves. So he cannot reach more distance. Then the light source itself, depending on the angle, it will reflect on this, so he will not reach this big distance on the multi-mode. To understand more, this is the multi-mode. Okay, this is the two type of the multi-mode cables, 50 by 125 micron and 62.5 by 125 micron. The advantage is that it's low cost. You can easily install it on the low level networks, which is inside the boundary of the buildings, between the floors, between the shops, between the building and the building, which is a small distance, up to 300 meter, 400 meter, you can install it. You can utilize this multi-mode, okay? But you will not reach more than 2 kilometers. Then if you want to connect with outside world and your network is multi-mode, you have to convert the signal. That means outside he will not deploy multi-mode because the distance between the exchange, computer exchange or Vodafone exchange, to your premises more than 10 kilometers, 7 kilometers. So he have to deploy single mode. To communicate with this multi-mode and the single mode, you have to do the media converter, which will cost you extra because every core has to be ported on the media converter. That means if you have one cable, 288 fiber, we need 288 media converter. which is too costly solution. So it's better to know your end point and source point and to make the same solution on the same level of network. Single mode, multi-mode. Okay? You cannot mix. If you want to mix, you have to put a media converter between the single mode to the multi-mode or multi-mode to the single mode.
And it is very costly.
It's very costly. You can imagine that one multiple media converter, it will cost you around $150 per unit. Okay, and you need from the both ends. If you have on the other side the same scenario, then you have to convert again.
Yes, right.
All of this points, cuts, terminations, adding loss of the signal, which will make your life as an operator miserable later on the maintenance and operation. So we have invented this single mode, which less cable, the diameter itself, okay, 9 micron divided by 125 micron, okay, can give you more than 70 kilometer, okay, can use it for multiple applications. Previously, it was too costly. Nowadays, for the last 10 years, the fiber optic price is not this much difference between single and multi, so you can use it easily. Okay. Still, there are some guys who's using multi-mode because when you design a network inside a building where you have data center and IDF rooms, does not communicate with outside, just only inside the building. There is no telecom service. Okay, just only for backboning, like government building. Okay, school. They want to just inside. In this scenario, you don't need single mode because it will end up on the active equipment, on the switch. So on the switch itself, it will do this conversion. So you have already active equipment will convert this between single mode or multi mode.
So it can be converted.
It can be converted on the switch. You will not pay extra for it. Okay? The switch will do this conversion. If it's single or multi, he will convert the switch itself.
So if we need to use multi-mode inside the building and inside the building only.
Single mode as a backbone, multi mode as a
Single mode as a backbone coming from outside.
يعني from Orido مثلا.
From Orido. Okay?
Okay.
And then inside the building, you
يعني
can
from
use-
Orido to up to ODF,
That's it.
right?
Okay?
And from ODF we can use multi-mode if we can use
But you have to have a switch
switch
to convert.
to convert.
So now the switch is making as a conversion level.
يعني sorry, you now mentioned active component.
That's it.
So
If
يعني
you have active equipment,
I need just يعني you to clarify what is the difference between the passive component and the active
Okay.
component, because maybe they don't
Good.
understand.
passive, where you have cables, nothing to connect to the power.
Nothing to connect to.
To the power.
Power, oh.
Electricity.
This is passive.
This is passive. Anything does not connect to the power cable, doesn't have a power source, it's a passive.
Okay.
Fiber optic, Cat 6, Cat 5, anything, patch panels, rack, it's a passive. Doesn't connect to the power source, to electricity source. Once you connect anything to the power source, to electricity source, it's active.
Okay.
Whatever this device is, it's active.
Good.
Okay? So this is the main difference. So on the passive terminology, yes, you can connect, but once you have this design on the building, okay, and again, based on the building structure itself, when you come to the school will have the switches.
Yes.
They will have their own switches, they will have their own network. So you will have, it's okay for them to connect multi-mode inside the building and single mode from outside, because the switch will work as a media converter.
Yes.
Okay? But if you have the solution inside the building, like the Lido and UFTH, they said, no, we will not put any active here. It's a passive connectivity, back-to-back connectivity. In this case, you cannot put a multi-mode and they will put a single mode. No. You have to comply with what they will do. which they have already, because of the distance, they have chosen to go for single mode. Okay, so you have to identify again what is my application, what is my source point, what is my end point. Based on this, you'll identify which solution I will use, single mode or multi mode. Yeah? On the development, okay, of the technologies, they develop multiple versions of the multi-mode cables. The multi-mode cables, where its technology of called MOM1, it can reach on the bandwidths of 1000 megabit, okay, up to 275 meter. When you want to transmit 10 giga, only 33 meters can go. Okay, so the main difference on the different type of the multi-mode cable, different versions in manufacturing, okay, they have identified OM1, OM2, OM3, and OM4. And you choose which one of these versions based on the data bandwidths you want to transfer, 1 gig, 10 gig, 40 gig, and 100 gig. And the distance, how much you want to go. Okay, on the OM1, 275 meter, when you transfer 1000 meg, which is 1 gig, the first point on the left. So AM1, 275 meter. If you want to transfer 10 gig, 33 meter. But on the OM1, you cannot go 40 gig. You have to change the technology from OM1 to OM3 if you want to go for a 40 gig. If you want to go for 100 gig, OM3 or OM4, but on the high level distance up to 150 meter. There is some technologies right now, OM4, some factories they develop up to 250 meter, where you have a big data centers and you want to use this existing infrastructure. Okay, you don't want to change it to single mode. No, use the existing multi-mode connectors and to put, so they can use the OM4 technology. Okay, so keep it in your mind, OM4, OM multi-mode, which is called optical multi-mode, 1, 2, 3, 4. This is the version of the multi-mode cables. Okay, OM1 and 2, you keep it for the small distance, okay, very, very short distance, and small bandwidths, very low bandwidths, up to 10 gig, which is inside the data centers. Usually they use it. Okay, but when you go to a little bit more, you need to go for OM3 or OM4, which will give you more bandwidths and more little bit extra meters distance. Okay.
If we need to change from OM1 to OM3, it is media inverter also?
No.
Media inverter?
No. No. OM1, the fiber itself, it's been manufactured as OM1 terminology. It works only based on this. Okay. If you want to change to OM3, you need to change the cable itself.
All the cable.
All the cable. Okay. If you want to go for more bandwidths. Okay. On the
okay. What make me to determine if I need 1 giga or 10 giga or 40 giga? It is related to the application itself.
The application.
CCTV or
whatever the application. Okay. You have, again, it's based on the application level. What you want to connect from the source A to the end point B. What is my application? If it's data transmission, video transmission, voice transmission, okay.
According to this, I choose.
Yes, backbone, okay, between two buildings, backbone between two machines, okay. Some of the industries does not require this much big data, but it's require more distance, okay, where you cannot deploy the single mode. It's inside the boundary, it didn't reach more than 500 meter, and you need just only 100 meter, 100 megabytes.
So I can choose this.
You can choose the multi-mode, yes. One of the factories, it's called here it's called Umubab area, okay, near Saudi Port. Okay, it's called Khalij Cement. Using this technology to connect the machines. Okay, so there, because you don't need this much big data, okay, so we give them OM3. But the distance is around 850 meters. So we came down from 10 gig to just give him 200 meg. You got it? Yes, I'll speak Arabic just for 2 minutes so everybody will be on the same page. بمنتهى البساطة، اوكي، كان عندنا فاكتوري، الفاكتوري دوت عنده مشكلة ان هو عايز يكونكت ماشينز، والماشينز دي داخل الباوندري بتاعته تتكلم في مسافة 500 متر 600 متر ل 800 متر، اوكي 850 اقصى حاجة. بس مشكلته ان هو عنده هناك كابلات مالتي مود كيبلز، والماشينز مش تتعرف على السنجل مود، ما فيهاش كونفرجن. اوكي، الماشينز اللي هو اشتراها قديمه قوي، اوكي، فكان لازم يبني مالتي مود. فعملنا سولوشن ساعتها ان احنا نستغل الاو ام 3 سولوشن، وبدل ما اديله 10 جيج ترانسميشن على 300 ميجا بس، لا انا عملت لها اكسباند 350 متر واديته عليها 200 ميجا، قللت الباندويث وزودت المسافه.
ده ينفع؟
ينفع اشتغل. لو انت رحت للجماعه بتوع الستاندردز يقول لك لا 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 جو سنجل مود. But on the practice, on the real life, it's working.
طب ازاي بقى؟
ازاي بقى ان انت تستغل السورس بتاع الفايبر، اللايت سورس بتاعك، اوكي، وبتقول لا انا ما خليتش الديستانس 300 متر بس عشان اخد ال 10 جيج، انا هستغنى عن من ال 10 جيج ترانسميشن دولت، هستغنى عن 9 جيج. فبالتالي اللايت سورس اللي جاي لي هيكون اتعمل له اوريدي ريدكشن، طول ما المسافه بتزيد بتعمل لللايت سورس ريدكشن.
مش هيستخدم الباندويث كله، هيستخدم اقل.
بالظبط كده، اللايت سورس بتعمل له ريدكشن، بيقل معايا، بيقل تدريجيا، هو ما بيقلش مره واحده ينزل من 200 جيج لل 100 ميج، لا هو بينقص معايا طول ما هو ماشي في الطريق. بيفقد جزء من قوته اللايت. اوكي، بيحصل له ريفليكشن، بيحصل له لوس، بيحصل له ديفيشن، كل دوت بيأثر على الباندويث بتاعت الكابل. فعشان انا طولت المسافه ل 350 متر، في النهايه اديته كام؟ 200 ميجا. على نفس الكابل بتاع المالتي، ان هو ما كانش عايز اكتر من 10 ميجا. يعني هو الابلكيشن بتاعته على الماشينز مش اكتر من 10 ميجا. فكان بالنسبه له 200 ميجا سمول انف. واشتغلت والحمد لله شغاله، مفيش اي مشكله بقى سنه دلوقتي. اوكي. نكست. هنا بقى الاو ام، الفرق ما بين الاو ام 1 والاو ام 2 والاو ام 3 بيشتغلوا في انهي ويف لينس. الويف لينس اللي انا بتكلم عليه في الاو ام 1 والاو ام 2 بيشتغلوا mainly 50 nanometer, okay, which give you up to 200 meter, okay. On this wavelength, if you want to go more than this, up to 500 meter, okay, you have to change the wavelength to 1300 nanometer. Okay. So, to utilize all of this, again, it's depend on the application, in start point and end point. What I want to do with this network. Okay, so they develop after this the new technologies between the wavelengths, okay, which between OM terminology, which is for the multi-mode, and OS terminology for the single mode. Optical multi, optical single. This is the definition between OM and OS. This is the difference, okay? And they started to say, okay, guys, on this OM terminology, okay, I can utilize the wavelengths 850 and 1300, okay, but the loss will be high. Once I go for AM1 or AM2, the loss of the cable will be high. This is the point of the loss. Yes.
كنت عايز اسال على حاجه في الحته اللي فاتت دي.
Please.
احنا يعني كده لو انا هغير من او ام 1 لاو ام 3
Yes.
او العكس، بستخدم اي موديول؟
لا.
ولا هو بس بعمل ترمينيشن في الكيبل زي ما هو سبلايسنج وخلاص؟
لا لازم you have to understand, okay, if you want to change from OM1 to OM3 or AM2 or AM4, okay, you have to understand what you have on the ground, which model of fiber you have, okay, and you have to understand if it is in the same wavelengths or different wavelengths, the transmission. That means if I will transmit on 850 or I will transmit on 1300, what is my transmission device?
Need data sheet.
You need to have a data sheet for the existing cable, which cable has been used, okay, based on the source machine. السورس دوت هيديك المعلومه, he will give you the information for which wavelengths he's using. لو عندك example, okay.
لا انا فاهم دي بس انت
then after this, okay, you have to identify if it's going to use the same wavelengths 850 ولا different lengths 1300.
if we use same wavelengths.
Same wavelengths, again, still the fiber you can splice.
Just
Okay, if it have to be 50 micron.
okay.
That's mean two types of the fiber have to be 50 micron. 50 micron. You cannot splice 62.5 to 50
Okay. Cannot.
to see it here. This is the difference. This is the 50 on the silver side.
Different core.
Yes, you cannot splice.
Yes, yes.
Okay, but have to be 50 to 50. So to make very straightforward message, okay, when you want to go for the low loss, high distance, high bandwidth, we choose, if it's short distance, OM4, long distance, OS2. Usually they use OS1 or 2 ISP, okay. This terminology on the ISP, that's mean inside the building. OSP outside the plant, which means the connectivity backbone between the building and outside world. This is called outside plant. The definition of the FUA, Fiber Optic Association, which say that outside plant, that means it's outside your boundary. Okay, عندك مبناك المنطقة السكنية بتاعتك أو البيلدينج بتاعك أو الفاكتوري بتاعك أو الفيلا بتاعتك, ده اسمه inside. براها, out of this, it's outside. Out of your factory, out of your building, out of your premises, it's outside. So this outside, usually they use the OSP, okay, the OS2 cables, and some of them is using OS1, okay, depend on the link. That's it. How many kilometers it will go. Okay. So
لو حابب فيديو معين وعايز تدخل تدور عليه يبقى لازم تروح على القوائم زي ما انتم شايفين. ما تنسوش تعملوا سبسكرايب ومتابعة صفحتي على اللينكد ان وعلى تويتر وعلى فيسبوك. شكرا، السلام عليكم ورحمة الله وبركاته.